In this part of the video, we'd like to look at the security levels. To determine the Nash equilibrium, the players looked in each other's games, but here they're going to look in their own game. So we've determined the Nash equilibrium point. Let's take a look at security levels. So the idea is that if you just ignore whatever the other player could do to you, you just play your best zero-sum strategy in your own zero-sum game. Well, playing your best strategy now, we're not just looking at equalizing strategy. We should see if there's any dominance, and there is dominance for rows, but there's no saddle point. It'll be the 2x2 subgame, which will have a mixed strategy solution. But we've already solved this mixed strategy game. Now, we did it with Collins' oddments, but in zero-sum games, the value will be the same when we do it with Rose's oddments. Look at Rose's oddments. 4 minus 4, 4 minus 8 is negative 4. 10 minus a negative 1 is positive 11. So we have 4 and 11. So those are the oddments, and you can verify that it's the same value of the game that we calculated, which was 5.6. Now, unfortunately for Colin, there is a saddle point, and it's at one of his worst possible outcomes. So remember, we're solving for your best game strategy. So here, if Rose is the minimizing player, and remember that we're analyzing Colin's game, so Rose being the minimizing player, she has this strategy is dominated by C, this strategy is dominated by C, and then Colin is stuck choosing between two pretty poor values, and of course he'll choose the one that's higher. So the security level for Colin is 0. Sorry, I grabbed the wrong graphic. So here's the payoff polygon, and we can show the Nash equilibrium. Sorry, and let me make sure this is all on the screen where we can see it. Oops. And then you can see the security levels. And the negotiation set is the part of the Pareto optimal boundary that is to the right of the security level for Rose and above the security level for Colin. So looking at the negotiation set definition, this just says in words what we just saw. And we know that the security levels are 5.6 and 0, so that's the point S. And you can see in the payoff polygon that this strongly favors Rose. Rose is doing much better getting over here towards her maximum. And Colin is well away from where his maximum values are. So whatever the final arbitrated solution is, it should reflect this initial advantage to Rose. So in the next video, we'll take a look at how the Nash arbitration scheme works.